Okay, now I'm back. I just got kicked off by the internet. So I just want to add all the constraint though, cancel. So let's go back to the solver. So now in the solver, I just put one constraint that all the parameters has to be greater than or equal to 0. So let's see if I want to add that, all the parameter, just randomly pick has to be less than or equal to 500. I can also do that too. So now I added the parameters. If you have a better estimate of the parameter, you can provide a better bounds for these parameters. But since I don't know anything, I'm just gonna do it. In order to use the GRG nonlinear solving method, then you need to specify the upper bound and the lower bound for all the changing cells. So I already did that. Let's see if I can solve for the optimal solution. Now, it said that solver converge in probability to a global solution. So it seems like I got a pretty good estimation of my parameters. I want to keep my solver solution and I click OK. Once I click OK, so this is what I have here. And my sum square error is only 42 compared to like a lot before I solve the program. Now my L is 118.176, my A and my B. I can plot these value to see if how close I am visually, so I can select the years, the actual data, and the forecasting data. And now I can click insert and then click chart. I'm sorry, I don't like that. I usually select this thing right here, the chart that I want, and I click OK. So basically, the red line is too big. Make it bigger. Okay, I can move the chart. Usually I want to move chart to be as a new sheet. So I just say, logistic forecasting curve. And then they have a new sheet here. As you can see that the red line is the Pearl forecast or the logistic forecast, and the blue line is the actual data. So, the logistic curve is not that bad in terms of predicting the trend of the data. One thing that we can do is that we might want to try to predict, what is the inflection point beyond this, 100 or 90 customer. So if we want to do that, as you can see from this function, since we already have a function, so we can do the forecast, right? So let's say we can try to see, try to forecast number of customer in year YEAR 20. So in order to do that, previously, you only have the data for 11 years. If you want to do it in year 20, then the number of customer X is going to be L, which is, 118.18. So it's 118.18 divided by 1 plus A. So A is 11.62. So this is 11.62 times e to the minus. B is 0.32. So this is 0.32 times year 20. So, if you calculate that, I can just do it real quick right here. So rather than having the year up until 14, we can do 15, 16, 17, and so on and so forth. If I do the pattern and I drag it down, it's going to go up until whatever year that is. And then I can do the forecasting value here. We can see that in the year 20, I'm expecting to sell, 115.91 per 100 customer in that year. So as you can see that it seems like the number of customer doesn't seem to increase a lot, like sometimes later on. So if I try to plot this in the curve more, let's see. Rather than selecting that, I want to change. So I say select data, and I want to select more data here by having more year, and then click close it. Okay. Oops. And I want to delete this year. I don't want year to be my data, so let's just delete year. Oops. Select data. Okay, I just take it out. Take the year out. Remove it. Okay, now I only have myself, the actual data. This is called cell phone per 100 and my pro forecast. And I'm saying, okay. So as you can see that, this logistic curve give me the prediction up until whatever year that I want. Seems like the inflection point is around, year 14. So in the year 14, my sales seem to decrease a little bit, and seem to be slowly. So I might want to have to think about a new product to sell later on. So okay, so this is one way that you can do it using the logistic curve, which is pretty cool, right?